So now we are going to solve this second order differential equation. So first we shall take up the homogeneous part, or before that let's just do one little thing, that is we'll just multiply the entire equation by 4 to get rid of the fractions. Okay, and now let's look at this homogeneous part first. So here is the homogeneous part, and if we assume that e to the power ms is a solution, mx rather, okay, is a solution, okay, then if we substitute y equals e to the mx in this homogeneous equation, what we shall get is this equation will yield or will produce this quadratic for us, m squared plus 4m plus 4 equals 0. Now this quantity factors as m plus 2 times m plus 2, or in short m plus 2 square. So what we have is that we have e to the, sorry about that, okay, one moment. Okay, so we have e to the negative 2x, okay, and again I'm repeating e to the negative 2x. So what do you do? I have these repeated roots, so to make them linearly independent we can multiply this by x, and you can verify that it still works in the differential equation. So these are the two linearly independent solutions, okay, and in the pen, see, I have this monitor awkwardly aligned. So anyways, so now we have our complementary function, which is the general solution of the homogeneous part, is c1 times e to the negative 2x, okay, and then plus c2 times x times e to the negative x. Now for this side, for this right hand side, we have to get a particular integral, okay, so it's a quadratic in x, all right. So what we would do is that we shall assume that our particular solution is a quadratic in x and see if it works out. All right, and remember this, that you have these suggestions, okay, which will be, you know, from your textbook, that what kind of forms to assume for particular integrals, provided that that particular portion has not already occurred in the previous solutions. Okay, so in here we are assuming that our particular integral is again a quadratic in x. So we have ax squared plus bx plus c as assumed our quadratic particular integral. So what we will do now is we shall differentiate it, take the second derivative and substitute that in the original equation, just to make sure, just to obtain the coefficients a, b and c. So if yp, or the particular integral, is this expression, then its first derivative is how much? We shall just use the product rule, and we know these quantities a, b and c are constant. So bx, the derivative is b, and here it is c. And then when we go for the second derivative, now we have 2ax, a is a constant, so this becomes simply 2a, and this will be a b. So now going back to the original equation, we can take this one without any loss of anything in here, okay? And so what happens here is that we are, if this is the differential equation and yp is a particular solution, then yp, that particular function, will satisfy this differential equation. So what we should have is, we should have this, then this, and this here. So let's go ahead and substitute these values from here. So you have yp double prime as 2a, as you can see right here. So that is actually 2a plus 4 times yp prime, and how much is that? That is 2ax plus b, and when you have plus 4 times simply yp, the particular integral. So let's just bring it down here, and then this has to match what? This has to equal this quantity on the right hand side. So we shall compare the coefficients, okay, and obtain the solution. All right, so let's just go ahead and collect the like terms. So first, as coefficient of x square, what we have here is 4a. So there is only one term containing x square and the coefficient is 4a. So we just leave it like this. Then for x, we got 8a here and 4b here, right? So you have 8a plus 4b x, and then plus you have 2a plus 4b plus 4c is our constant portion. So we got 2a plus 4b plus c, and let's put parentheses around here, okay, and that equals how much? 4x square minus 8x, right? So if I compare the two sides, what do I find? That this quantity 4 has to equal this 4a. So 4a equals 4 is going to produce a equals 1 for us, right? And then next, this quantity or this value negative 8 has to equal this quantity here, the coefficient of x. So what we get is that 8a plus 4b, that equals how much? Negative 8. So here we get this, that a is 1 as we just saw. So if we substitute a equals 1 here, so what shall we get by substituting a equals 1? Here is our a equals 1. So we are going to get 4b equals negative 16, and that means b equals negative 4. Okay, and now you can see this is the constant on the left hand side. There is no constant term on the right hand side. So this term will have to be 0, and we will substitute the values of a and b from the previous part. So let's do so. Okay, so we have a is 1, b is how much? Negative 4, right? So what was it? 4 times negative 4. Okay, I'm thinking a little ahead. So we got this, okay? And so before proceeding further, let's make sure we didn't do any algebra mistakes over here. Okay, so we had 2a, and then here we brought 2a correctly, then 4b correctly, and what I see is when I looked up, I noticed that instead of 4c I wrote a c here. So let me correct it, and it's again a lesson that be careful in this. So we are computing our c now. Okay, so I have 2, and 2 plus negative 16 would be, sorry, 2 plus negative 16 would be negative 14, right? And so this is going to give us what as value of c? C will be 14 over 4, or how much? 7 over 2 if we simplify it. So in here, if we go back and see what our particular integral is, sorry about that, here is, let me just bring these both down here. So now we have the function that will complement this particular integral is this, and our a is 1, b is how much? Negative 4, and c is 7 over 2. Okay, so the general solution here will be what? That will simply be y equals the complementary function plus the particular integral, or vice versa. Okay, so here we go. So yc plus yp is our final solution, which is going to be this here, that the complementary function is or rather a complementary function is this, and our particular integral here is this. So this will be general solution of the given differential equation. Let me know if this is not clear. All right.